Comparing linear, exponential, and quadratic functions. Linear functions uses the slope-intercept form y equals mx plus b, and it's normally in a straight line. Exponential functions, y equals ab to the power of x, it goes close to x axis, but it does not go over the x-axis, whether it be positive or negative. In quadratic functions, ax squared plus bx plus c, it is in a form of parabola, whether it be upward or downward parabola. Use a graph to identify the functions. Plot the points and tell whether the points appear to represent a linear, exponential, or quadratic function. First point is 4, 4 for A, 4, 4, 2 and 0, 0, 0, 1 and negative half, which is somewhere here, and negative 2 and 4. If I was to graph this, it's going to look like a parabola, correct? Let me graph this a little bit nicer. That looks like a parabola. So this is going to be a quadratic function. In B, we have 0 and 1, 2 and 4, 4 and 7. It's going to be somewhere around here. Negative 2 and negative 2. And negative 4 and negative 5. This looks like it's going to be a linear function. In C, we have 0, 2, 0 and 2, 2 and 8. I'm going to climb by 2 here. So I'm going to have 0 and 2, 2 and 8, 2, 4, 6, 8, 1 and 4, negative 1 and 1 here, and then negative 2 and half. It's going to be somewhere around here, okay? So this looks like a exponential function. So difference in ratios of functions. You can use patterns between consecutive pairs to determine whether which of the function models the data. So difference of consecutive y values are called first difference. So think of that. And that is most likely going to be what we call the linear function if we have a first difference. The difference of consecutive first difference the difference of second consecutive first difference are going to be called second differences, and those will be your quadratic function. Okay, so remember the linear is a straight line, and normally we have a positive and negative. Exponential, you're dealing with division and multiplication, and you will find what we call the common ratio. Okay, in all cases, the difference of consecutive x values need to be constant. Okay, so think of linear as a straight line, exponential that it's going to go close to x but not over to x. And it also could be also negative, which would be in the form of this, correct? Then we have quadratic functions, which is your parabola, upward or downward, and also in your linear, which you have your negatives. Using the difference of ratio to identify the functions. So between x, we have negative 3 and negative 1. This is adding by 1. Between negative 2 and negative 1, it's adding by 1. Negative 1 and 0 is adding by 1. And 0 and 1 is adding by 1. In y, between 11 and 8, we have negative 3. 8 and 5, negative 3. 5 and 2, negative 3. And 2 and negative 1, we have negative 3. Therefore, this is, remember what we said in the previous, it is the first difference, which is going to be basically where you're adding negative 3. So this is going to be a linear function. And B, between -2 and -1, we have +1, -1 and 0, +1, 0 and 1, +1, and 1 and 2, we have +1. Here we know that between 1 and 2 could be +1. But when right away I see that I have on the next one between 2 and 4, it's not going to be +1. So this is going to be times 2, because 1 times 2 is 2, 2 times 2 is going to give me 4, 4 times 2 is going to give me 8, and 8 times 2 is going to give me 16. And this is the ratio, right? So this is going to be an exponential function. And C, we have -2 and -1 gives me +1. -1 and 0, we have positive, adding 1. And 0 and 1, we adding 1. And 1 and 2, we have 1. Between -1 and -2, we have a -1. And -2 and -1, we have a +1. -1 and 2, we have a +3. Don't forget, remember your number line, you have -1, 0, 1, and 2. And between 2 and 7, we have +5. So this is what we call our first difference, because it's not linear nor exponential. So this is going to be a first difference. So before we say that it's not a function, let's do a second difference, okay? So we're going to have between -1 and +1, we're climbing by 2. Remember, we have -1 and 1. Between 1 and 3, we're going to have +2. And 3 and 5, we're going to have +2. So now we could say that this is going to be our second difference. Let me write this again. It's going to be our second difference. Therefore, this is going to be quadratic. Again, plot the points to tell what type of function it is. We have -1 and 5. Let me use the highlighter. We have 2 and -1, 0 and -1, 3 and 5, and 1 and -3. So that looks like a parabola, correct? So this is going to be quadratic function. And number 2, we have -1 and 2, -2 and 8. I'm going to climb here by 8 because I see this 2, right? This 32. Even though I have the halves and the 1/8, I'm just going to try to make it very small. Okay, we're going to climb by 8. So we're going to have -2 and -1 and 2. It's going to be somewhere, there. Then we have -2 and 8, -3 and 32. So 8, 16, 24, and 32. Correct? Then we have 0 and a half. This is going to be extremely small, okay? So 0 and a half, it's somewhere very small there. And then 1 and 1/8. Right? So by looking at this, looks like it's getting close to the x-axis, but not is over yet, right? So this is what we called a exponential function. And number 3, I'm going to graph -3 and 5, 0 and -1, 2 and -5, -4 and 7, and 1 and -3. I have not graphed yet the other one, but I know with -4 and 7 it's going to be somewhere down here, okay? That is giving me a linear function. Tell whether the table of value represents linear, exponential, or a quadratic function. So between -1 and 0, we have +1, 0 and 1 +1, 1 and 2 +1, and 2 and 3 +1. I know that between 1 and 3, it's going to be +2, but I have a 9 before. After the 3, right? So I'm going to have times 3. 3 times 3 gives me 9. 9 times 27 gives me 9 times 3 gives me 27, and 27 times 3 gives me 81. Therefore, this is a exponential function.